Picture this. Every single rainbow trout sold commercially in the United States is farmed. Zero exceptions. Not one wild-caught trout reaches your supermarket. This isn't a secret the industry hides. It's actually a point of pride, because what you're about to witness is one of the most sustainable, efficient, and scientifically advanced food production systems on the planet. We're talking about a fish that converts feed to protein at a near 1-to-1 ratio. 1 kilogram of feed equals almost 1 kilogram of fish. That's better than chicken, better than pork, better than almost any other animal protein source. And in the next 10 minutes, you'll discover why scientists call rainbow trout the farmer's fish. You'll see technology that detects bone fragments smaller than 0.5 millimeter. You'll understand why Idaho produces 75% of all American trout. And you'll learn facts that will permanently change how you see that pink fillet in the grocery store. Let's start with something that will surprise you. Rainbow trout aquaculture began in the 1880s, making it one of the oldest forms of fish farming in North America. The first trout hatchery opened in California, and within decades, the industry spread across the country. Why trout? Because these fish are absurdly easy to farm compared to almost anything else. They tolerate a wide range of conditions. They eat commercial feed without complaint. They grow fast, and they don't fight confinement the way some species do. Scientists literally call them the farmer's fish because they're so cooperative. But here's what most people don't know. Modern farmed trout are not the same as their wild ancestors. These fish have been selectively bred for over 100 years. They've been optimized for growth rate, disease resistance, flesh quality, and feed efficiency. The genetic lines used today bear the same relationship to wild trout that dairy cows have to wild cattle. They're domesticated, and the optimization goes even further. Most commercial trout farms now use all-female stocks. Why? Because female trout grow 20 to 30% faster than males. How do you get all females? Through a process called sex reversal. Eggs from normal female broodstock are fertilized with sperm from fish that are physically male but genetically female. These fish were treated with male hormones as fry, which reversed their sex without changing their chromosomes. The result? All female offspring. No genetic modification, no inserted or deleted DNA. Just clever manipulation of biology. Some farms go one step further and create triploid fish. These are sterile fish with 3 sets of chromosomes instead of 2. Why does sterility matter? Because fish that can't reproduce divert all their energy into growth instead of egg or sperm production. They grow faster and maintain better flesh quality. But wait, there's more science. A female rainbow trout can release up to 12,000 eggs when she spawns. And spawning happens in early spring when water temperatures hit 50 degrees Fahrenheit. In the wild, these eggs would be fertilized naturally. In aquaculture, workers literally strip the eggs from females by hand and mix them with milt from males. This process, called artificial spawning, gives farmers precise control over genetics and timing. The eggs develop in temperature-controlled hatcheries. At optimal temperature, around 50 to 55 degrees, they hatch in 4 to 6 weeks. The tiny fry absorb their yolk sac for the first month. Then they start eating. And once they start eating, the growth is remarkable. Here are the numbers that matter. From fry to market size, 8 to 10 ounces takes 8 to 12 months under optimal conditions. That's incredibly fast. But some operations grow them larger. 1 to 2 pounds takes 12 to 18 months. And in exceptional cases, trout can reach 3 kilograms, about 6.5 pounds, in less than 18 months. The growth rate depends entirely on water temperature and feed quality. The sweet spot? 59 degrees Fahrenheit. At that temperature, with high-protein feed, trout metabolism runs at maximum efficiency. Too cold, and growth slows. Too warm, and stress increases. This is why geography matters so much. Idaho didn't become the trout capital of America by accident. The state sits on massive underground aquifer systems that produce crystal clear spring water at a constant 50 to 55 degrees Fahrenheit, year-round, 24 hours a day, unlimited volume. This is liquid gold for trout farming. The water emerges from the ground already oxygenated, already at perfect temperature, already filtered by underground geology. No heating, no cooling, no treatment. Just gravity flow through concrete raceways arranged in stair-step configurations. Idaho produces 70 to 75% of all rainbow trout raised in the United States. We're talking about $41.45 million in trout sales from just 21 farms in Idaho alone. The next closest state, Washington, produces 26.15 million. North Carolina is third with 9.77 million. The total U.S. trout industry, $134.1 million in sales across 335 farms in 36 states. Now let's talk about what makes this sustainable. Feed conversion ratio. This is the holy grail of animal agriculture. How much feed do you need to produce 1 kilogram of animal? For beef cattle, about 7 to 1. 7 kilograms of feed for 1 kilogram of beef. For pigs, 3 to 1. For chickens, 1.8 to 1. For farmed rainbow trout, 0.8 to 1.5 to 1. In ideal conditions, you get almost 1 kilogram of fish from 1 kilogram of feed. This is extraordinary, and it gets better. Modern trout feed uses alternative proteins, black soldier fly meal, yeast-derived proteins, reduced dependence on wild-caught fish meal. Some formulations include up to 50% insect protein, with no negative effect on growth or survival. In fact, trials show 95% survival rates and improved feed conversion with insect meal. The fish in fish out ratio, the amount of wild fish needed to produce 1 pound of farmed fish, has dropped to 0.5 to 1 or less. You're putting in less wild fish than you're getting out in farmed product. Water use is another sustainability win. Most trout farms use flow-through systems, meaning water flows through the raceways once and exits downstream. This sounds wasteful, but it's actually non-consumptive. The water isn't used up. It flows through the farm and continues downstream. And because trout require such clean water to survive, farms have a financial incentive to prevent pollution. Contaminated water kills trout, so farmers protect their water sources obsessively. Some operations are even moving to recirculating aquaculture systems, RAS, where water is filtered and reused. These systems reduce water consumption by 95%, but require more energy and capital investment. Let's jump to the processing facility. From the moment live trout arrive from the farm, the clock is ticking. But unlike ocean fishing, where fish might be dead for days before processing, these trout are alive until minutes before processing begins. They're transported in aerated tanks that maintain optimal temperature and oxygen. The journey from farm to processing plant in Idaho typically takes less than 30 minutes. Upon arrival, fish are held in clean water for 72 hours without food. Why? To evacuate their digestive tracts. This 3-day starvation period ensures the gut is empty, which improves hygiene during processing and extends shelf life of the final product. Then comes stunning. Modern facilities use electrical stunning, which renders the fish instantly unconscious before any processing begins. This is humane slaughter, and it's also quality control. Stressed fish produce lower quality meat. The flesh can become soft, the flavor can turn sour, and the appearance degrades. Calm, unstressed fish at the moment of death produce superior product. After stunning, the process moves with industrial precision. Automated washing with ice-cold water at 22 psi pressure. Gill cutting for bleeding. Removing the head at a precise angle to maximize meat yield. Evisceration with vacuum extraction of internal organs. And here's a detail that matters: the bloodline removal. Along the spine of every trout is a strip of dark, highly vascularized meat. This bloodline has a stronger flavor and can cause off tastes if not removed. Professional processors scrape it out completely. Now we enter the technology zone. After filleting, each trout fillet passes through multiple scanning systems. First, three-dimensional laser scanners project green light grids onto the fillet surface, creating a topographic map with sub-millimeter accuracy. Any irregularity, any bone fragment sticking up gets detected. Then X-ray. Every single fillet is radiographed. The system can detect bone fragments as small as 0.4 millimeters. That's smaller than a grain of rice. If a bone is detected, a jet of compressed air automatically ejects the fillet from the production line. Then metal detection. Because even with the most careful processing, a fragment of a knife blade can break off. The electromagnetic field is so sensitive, it can find metal particles the size of a sand grain. This is food safety at a level most people never imagine. Color grading comes next. Rainbow trout flesh can range from white to deep pink, depending on diet. Wild trout that eat crustaceans develop pink flesh from natural carotenoid pigments. Farmed trout are fed pellets that may or may not include color additives. Some markets prefer pink trout that looks like salmon, others prefer white. The optical scanner sorts them automatically. Weight grading follows: 4-ounce portions, 6-ounce, 8-ounce. Each fillet is weighed to 0.1 grams and sorted accordingly. The premium grade, uniform color, perfect size, no defects, goes to high-end restaurants and specialty retailers. Everything else goes to different markets. But nothing is wasted. Quality control doesn't stop at visual inspection. Random samples go to the lab for microbiological testing. Petri dish cultures check for bacterial contamination. pH meters measure flesh acidity. Fresh trout should have a pH around 6.8. Temperature probes verify that product temperature never rises above 38 degrees Fahrenheit. Moisture content analyzers ensure the flesh hasn't dried out or absorbed excess water. Every batch must pass every test before it can be packaged. Packaging varies by market. Fresh fillets for supermarkets get placed on styrofoam trays with absorbent pads to catch any liquid. Clear plastic film is heat-sealed over the top. A label with batch codes, nutritional information, and a best-by date gets applied. Vacuum-sealed portions for food service distribution get different packaging. But the most fascinating is IQF, individual quick freezing. Fillets enter a tunnel at -40 degrees Fahrenheit. Within 7 minutes, the core temperature drops from 36 degrees to -35 degrees. This rapid freezing forms microscopic ice crystals that don't damage cell membranes. When you thaw IQF trout, the texture is almost identical to fresh. Compare this to slow freezing, which creates large ice crystals that puncture cells. Slow frozen fish drips water and turns mushy when thawed. IQF changes everything. After freezing, fillets get a glaze, a thin spray of water that immediately freezes into a protective ice shell. This 1 millimeter coating prevents freezer burn and oxidation, extending shelf life by 6 months. Then automated bagging, vacuum sealing, and cartoning. Robotic palletizers stack boxes onto wooden pallets. Plastic film wraps the entire pallet, and everything goes into cold storage at 0 degrees Fahrenheit until shipment. Now the question everyone asks: is it safe to eat? Let's talk mercury. Rainbow trout is in the FDA's best choices category. This is the lowest mercury classification. The fish that are safest for everyone, including pregnant women and children. Trout mercury levels are so low that there are no consumption restrictions. Eat as much as you want. Compare this to swordfish or shark, which pregnant women should never eat, and you realize trout is a completely different category. Why so low? Because trout are farmed in controlled freshwater systems. They don't bioaccumulate mercury from ocean food chains. They're harvested young before they can accumulate significant contaminants, and they're fed clean, controlled diets. Nutritionally, trout is impressive. 0.6 grams of omega-3 fatty acids per 3-ounce serving. That's not as high as salmon, but it's significant. Omega-3s reduce inflammation, support heart health, and aid brain development. Protein content is high, fat content is low, and farmed trout actually has higher omega-3 levels than wild trout because of the enriched feed. Studies show farmed rainbow trout can have 3 times more omega-3 than wild counterparts. The trade-off? Slightly higher total fat, but we're still talking about lean fish. What about contaminants? PCBs, polychlorinated biphenyls, are a concern with some farmed fish, but studies on farmed rainbow trout show relatively low PCB levels, well within safety limits. This is partly because trout are farmed in freshwater systems, isolated from industrial pollution, and partly because they're harvested young. Contaminants accumulate over time. A fish harvested at 12 months has far less contamination than a fish that lived 15 years in the ocean. Sustainability is where trout truly shines. The Monterey Bay Aquarium Seafood Watch program gives U.S. farmed rainbow trout a best choice rating. This is the highest sustainability category they offer. Why? Near 1-to-1 feed conversion, non-consumptive water use, low disease rates reducing antibiotic use, fast growth reducing time to market. And because they're farmed, there's zero impact on wild fish populations. You're not depleting ocean stocks, you're not destroying habitat with bottom trawling, you're growing protein in controlled systems with minimal environmental footprint. The global rainbow trout market is valued at $5.2 billion in 2025 and projected to reach $6.8 billion by 2030. That's a 5.7% annual growth rate. Europe leads with 36% of revenue thanks to cold water infrastructure in Norway, Scotland, and the Nordic countries. Asia Pacific shows the highest growth rate at 8.2% annually. Chile is the world's largest producer, leveraging technology from their massive salmon industry. But the United States remains a major player, especially for domestic consumption. From underground Idaho, aquifers pumping crystal-clear 50-degree water through concrete raceways where fish convert feed at near-perfect efficiency, to processing facilities where sub-millimeter bone detection and X-ray imaging ensure absolute quality, to frozen tunnels at negative 40 degrees creating microscopic ice crystals, to your dinner plate where pink fillets deliver omega-3s and protein with minimal mercury. This journey you just witnessed represents over a century of aquaculture refinement. It's the story of a fish so cooperative that scientists call it the farmer's fish, so efficient that it converts feed better than almost any other animal, so sustainable that environmental groups rate it best choice, and so safe that pregnant women can eat it without restriction. The next time you see rainbow trout at the supermarket, you'll know it came from a farm, probably in Idaho. You'll know it was bred from genetic lines optimized over generations. You'll know it grew to market size in less than a year. You'll know it was processed with technology that can detect bone fragments smaller than a grain of sand. And you'll know it's one of the healthiest, most sustainable protein sources available. If this journey fascinated you, if you learned something new about aquaculture and food production, leave a like and comment what surprised you most. Was it the all-female stocks, the near 1-to-1 feed conversion, the X-ray bone detection, or something else? And subscribe because we're investigating salmon next, and that story is even more complex. It's important to clarify that the process presented in this video is 100% fictional, and all images are merely illustrative, generated by artificial intelligence for educational purposes. The facilities shown do not represent specific real factories, but rather a recreation based on real industrial processes documented and verified. The information presented was based on verifiable data from USDA National Agricultural Statistics Service trout production reports, NOAA fisheries, data on domestic aquaculture, FDA Food and Drug Administration, fish consumption advisories and mercury databases, United States Trout Farmers Association, industry statistics and best practices. Agricultural Marketing Resource Center, Trout Production and Market Information. Monterey Bay Aquarium Seafood Watch, Sustainability Assessments for Farmed Rainbow Trout. Peer-reviewed scientific studies on aquaculture efficiency, feed conversion ratios, and nutritional content.